So we've talked about models. Now we want to talk about equations and where they come from. Now the thing is that actually the difference between equations and models is very, very subtle at times anyway. And so, you know, suppose we have a model, you know, for pay from hours worked. Okay, so you might have pay P is equal to, and say you're an hourly worker at $14 an hour, well, that'd be 14 times H, the number of hours worked. And there's a model. Now, I see an equal sign. Looks a lot like an equation, right? Because we've got an equal sign there. Well, it can be an equation. And that's where things can get subtle. Is here, you know, I'm defining a relationship in terms of I want to get my pay from my hours worked. And in mathematics, we tend to just use an equal sign there. But really, it's more of an assignment in this model case. You know, I'm saying, you give me the hours worked, I'll tell you the pay. So it's really sort of going that direction. You know, if I work 2 hours, that's 2 times 14 or $28. Okay, now, but where it becomes an equation is I could ask, how much pay do I get from 4 hours work? And I could say, well, this is an equation because I can set this up, 4 hours work, so that's 14 times 4, and that's equal to how much pay. And now I'm thinking of it as an equation. And it's a pretty simple equation to solve. In this case, P is just equal to the 4 times 14, or 56. And that'd be dollars, I guess, in this case. So there was an equation. Similarly, I might ask, how many hours must I work to get let's say $70 in pay? Well, and that sets up this equation again, an equivalency, because I know that if I take 14 times my H, that should be equal to, 14 times my number of hours, that should be equal to the number 70. And so now I get this equation. Now this equation is a little harder to solve in that I don't have H all by itself. It doesn't just tell me the answer. And so, I'd have to use a solution technique, and we're going to look at those as well. In this case, if I divide both sides by 14, 70, On the left side, oops, I want that 8. On the left side, I get H, and on the right side, I get my 5 hours. Okay, so typically equations come from asking questions or setting bounds. Okay, there's the bottom of my page. Okay, so another place they may come from is, you know, I set bounds on things. Okay, so for instance, we're going to talk about in this course, you know, throughout the rest of the course, we'll bring up things like, you know, we want to allocate staff to crisis centers. Okay, so we may end up saying that, well, okay, we're going to have 2 crisis centers. And we'll say the number of, we'll call S1 the number of staff at crisis center 1, and S2 the number of staff at crisis center 2. Okay, and then we may impose something like we need 20 staff total. Okay, now we can write that out as an equation, because, right, my number at center 1 plus number at center 2 is equal to the total number. And notice I did this, I'm thinking of it in English. Okay, but now I've got symbols for the number at center 1. That was S1. And I've got a symbol for the number at center 2, that's S2. And I know my total number I said is 20. And there's an equation. Okay. Now then, similar to that though, so, you know, I may say I need 20 staff because of the populations I need to serve or something like that. But I may also have to worry about a budget. And, you know, let's say on average, a staff member costs now, you know, there's benefits and all these different things. So I'm going to say $60K or $60,000 a year at center 1 and just say 40,000 a year at center 2. Now this is very possible because this first center, maybe that's urban and the second center is rural, so costs for renting space or buying property or various things like that may be much cheaper in the rural area than in the urban area. And now suppose then I have a budget of $1 million or 1,000. Okay. Now, what that says is if I take number of staff at center 1 times 60,000, I'll just call it 60, plus the number of staff at center 2 times 40,000, that I would like that to equal my budget. Well, so that's I'll write the number first, so 60S1 plus 40S2 is equal to 1,000. So there's another equation. And actually, what we end up often wanting to do is know, can we satisfy both of these at once? So can both staffing and budget work at once? And so we're asking, can we have S1 plus S2 equal to 20 and 60S1 plus 40S2 equal to 1,000? And we'll look at how we can solve those. We'll look at it algebraically. We'll look at it in Desmos. But the question is, can both of those happen at once? In other words, can I say S1 equals something, S2 equals something, and have these both work? And actually, as it turns out, I made this up myself, so I know that 10 and 10 work. And so that would be a solution, because 10 here, 10 plus 10 does indeed equal 20. And if I take 10s in here, I'll get a 600 plus a 400, and that does indeed equal 1,000. Okay, but generally we don't make it up, so we would need some sort of solution technique to find this. But this is where our equations are coming from. They're coming from requirements or constraints is another word for it, that we have in real life that we can write down in terms of symbols that have to do with numbers, and then the equality of numbers. Okay, so that's where our equations are coming from.